Welcome everyone to our ARSET training series, Introduction to Advanced NASA Earth Observations and Tools for Active Fire, Smoke, and Post-Fire Monitoring. Today is part one of our training series, Post-Fire Imagery and Smoke Monitoring. My name is Brock Blevins. I'm a training coordinator for the ARSET program, and I'll be your host for this training series. But before we begin today's training, a few quick words about the ARSET program. NASA Applied Remote Sensing Training, or ARSET program, provides cost-free training on the use of remote sensing observations, analysis methods, and tools. We provide training in several thematic areas: agriculture, climate and resilience, disasters, eco-conservation, health and air quality, water resources, and such as the training here today, wildland fires. ARSET provides trainings both online or in person. Our online trainings are delivered in two formats: live and instructor-led, like today's training, or asynchronous and self-paced. Like NASA's free and accessible data, all of our trainings are offered at no cost. We try to offer trainings in more than one language whenever we can, and we only use no-cost and open-source software and data. We offer our trainings at a range of levels, so you can find a training series that fits your level of experience and need. Please visit our website to learn more. We'll begin today's session by giving an overview of the training series, Advanced NASA Earth Observations and Tools for Active Fire, Smoke, and Post-Fire Monitoring. Consistent and routine monitoring of active fires, smoke transport, and post-fire burn severity is essential for understanding both the immediate as well as the long-term impacts of fire on ecosystems, air quality, and human infrastructure. Satellite observations provide continuous and often global data that allow for early detection of new fire ignitions, the tracking of fire progression, and monitoring of smoke transport. These data can help guide emergency responses, reducing risk to communities. Post-fire, burned area, and burn severity maps can be used for damage assessment, evaluation of vegetation loss, and debris flow risk assessment. This information can help scientists and land managers support recovery efforts. Overall, satellite monitoring is a key tool for both immediate fire response and long-term environmental management. And here are our training learning objectives for the series. By the end of the training, participants will be able to access relevant post-fire imagery in the firm's burned area mode to assess burned area, burn severity, and other factors. Identify and track wildfire smoke over time using corrected reflectance, OMPS aerosol index, and pyro-CB layers available in the firm's smoke aerosols mode. And also understand when to use the pyro-CB layer. Use relevant data and firms to identify static thermal anomalies associated with industrial and natural sources that are not vegetation fires. And use Jupyter notebooks to assess and visualize firms' data for different case studies. A prerequisite for this course, we recommend that you take our fundamentals of remote sensing to familiarize yourself with the terminology and concepts you might hear in today's training or have equal knowledge coming in. This training also builds on a previous ARSET training, Introduction to NASA Earth Observations and Tools for Wildfire Monitoring and Management. This training gave an overview of the NASA Fire Information and Resource Management System, or FIRMS, the modules available in FIRMS. We explored the data as well as the characteristics of available satellite-based active fire detection and provided demonstrations on how to query, access, and visualize the data in GIS and other applications. This training will also discuss burned area and indices for burn severity. So for more information on those, we recommend reviewing our previous training, Spectral Indices for Land and Aquatic Applications. So here's our training outline. In part one today, we'll be covering post-fire imagery and smoke monitoring. And then in part two, a week from today, on November 19th, we'll be looking at data analysis and visualization. There'll be one homework associated with this training, and it will be available on November 19th, on the day of our last session. And it will be due 2 weeks from there, due November 3rd, and that will be posted on the training webpage. A certificate of completion will be awarded to those who attend all live sessions and complete the homework assignment before December 3rd. So let's start part one. Our Part 1 trainers today, we're lucky to have Jenny Hewson. She is the Lance Manager, and Diane Davies, who is the Lance Operations Manager. And the objectives for the part today, participants will be able to recognize the strengths and limitations of available post-fire indices and imagery products in the burned area mode, access available indices and imagery products and firms to assess burned area and fire damage severity, burned area recovery status, and other land cover characteristics. Recognize the strengths and limitations of available smoke and aerosol data products and firms. And this will be used for monitoring smoke extent and tracking progression. And then how to access available satellite data products and firms that can be used to track the extent and progression of smoke. This is a reminder of some of the key concepts we'll be using during today's session. If you're completely unfamiliar with these, you can refer back to our recommended prerequisites. One is true color imagery is used to show an image as a human eye would see it. It uses red, green, and blue wavelengths to represent the corresponding colors in the real world. False color imagery is created by assigning wavelengths invisible to the human eye, such as infrared, to colors like red, green, and blue. False color imagery is used to enhance surface features like the presence of vegetation or a burn scar. A spectral index combines different wavelengths of light to highlight specific features on the Earth's surface or atmosphere. Different indices can give information on the health of vegetation, water quality, burn severity, the presence of aerosols, and more. Examples of these referred to in Part 1 are the normalized burn ratio, or NBR, the normalized difference vegetation index, NDVI, and aerosol index. How to ask questions. Please put your questions in the questions box and we'll address them at the end of this training. Feel free to enter your questions as we go. We'll try to get to all of the questions during the Q&A session after the training. The remainder of the questions will be answered in the Q&A document, which will be posted to the training's webpage about a week after the training. So now I will hand this off to Jenny Hewson, who will start us with burned area mode in firms. Thank you, Jenny.
Okay, great. Welcome to this demonstration using firms to map and monitor burned area and post-fire dynamics. The demos will provide an overview of the firm's burned area interface and global burned area products, and an overview of the vegetation indices and other imagery available to analyze burned area and post-fire dynamics for a particular area of interest. By the end of this session, you should be able to assess burned area globally using the monthly and annual burned area products available from MODIS and VIAs, and be able to analyze burned area and post-fire dynamics for a particular area of interest using vegetation indices and other imagery from the harmonized Landsat Sentinel dataset. There are two global burned area products that can be accessed through the burned area mode as well as the advanced mode, which you can access here. There is the NASA MODIS monthly burned area product, as well as the NASA VIA's monthly burned area product. The MODIS burned area product is generated using MODIS on Terra, as well as MODIS on Aqua. The VIA's product is generated using VIA's aboard SMPP. The MODIS product is available from late 2000, and the VIA's product is available from early 2012. If I change this to 2025, you will notice that the products are available, both the MODIS product as well as the VIA's product, through August of this year. And that is because the products are based on a burned area algorithm that uses a time series of reflectance imagery to identify abrupt changes in reflectance. The algorithm then checks for the persistence of this abrupt change and then uses a series of active fire detections to double check these changes resulted from wildfires. This process can result in a lag of anywhere from 2 to 4 months. Now, as they are both based on the same algorithm, the VIAS uses a modified version of the MODIS burned area algorithm. This ensures that the VIAS product will provide continuity to the MODIS product once Terra and Aqua, which both carry the MODIS instrument, are decommissioned. And both products also have the same spatial resolution, 500 meters. Other options to note on the interfaces, again, the interfaces are identical. There is the monthly product that is available, and then there is also an annual cumulative product. The monthly product can be viewed for 1, 2, or 3 years simultaneously. For example, you can change the dates to any year of interest, and then the relevant year will pop up, at which point you can manipulate which of the layers, which of the months you would like to view based on your area of interest. You can change the colors here, and you can change the opacity of a particular month using this tool. You can also decide whether you want the months filled or would like to use an outline instead. And then there is the annual cumulative product, and again you can look at this for 1, 2, or 3 years simultaneously. Okay, so that's the interface, and now we're actually looking at the Pantanal region in South America. It is the world's largest wetland, and it is located in this area of Brazil, Bolivia, and Paraguay. So all throughout this area here. The Pantanal generally experiences a dry season between June and October. And in 2023 and 24, the region actually saw a significant drought and a large amount of area burned. We are actually looking at, let me just collapse these down for a moment. We're actually looking at a MODIS aboard Aqua false color composite produced using bands 7, 2, and 1, and burned area in this composite shows up as a brick red color. You can also see active wildfires and smoke emanating from the wildfires in these areas here. We can now explore when the area is burned using the burned area product. Let me collapse a couple of layers and then open up the MODIS burned area product. So I changed this to 2024, and now I can look at the areas that burned and were mapped by the MODIS product in May, in June, in July, and in August 2024. As I mentioned, you can change the color of individual months, and so we're going to change June to more of an orange color because the green does not really stand out on the false color composite. And if we turn each of these layers off, you can actually see the burned area that was mapped underneath the burned area product generated by MODIS. Now, if we fast forward to the end of September and pop that on, we can see that even more area has burned. Again, there is smoke from some of the active fires, and this is all of the area that was burned from the end of August to the end of September. And if you wanted to compare the MODIS and VIAS burned area product, you pop down to the VIAS product and select the same year, 2024, and we will compare August. Now we're actually looking at August 2024 of MODIS and August 2024 of VIAS. And let me change the color of the VIAS product to a yellow so that we can now see both products. Veers is in yellow, and we can actually see how well the products generally correspond to each other, even though the products are from two different sensors, Modus and Veers, and these have different sensor characteristics. And if I zoom in and now pick up the opacity tool and slide back and forth, we can see how well the products overlap and any small differences that there may be. In fact, on average, the annual global difference between the two products is 2 to 6%, and this is all explained and documented in a recent paper by Giglio et al. That is in the references section. In this section, we're exploring other data layers that can be helpful in assessing burned area, post-fire dynamics, etc. We're using the FIRMS US Canada, and we're going to explore the harmonized Landsat Sentinel-2 imagery drop-down right here using the Mosquito fire in California. This was the largest fire in California in 2022. It started on September the 6th. It burned in 2 counties, Place and El Dorado. And just to orientate a little bit, to the east is Lake Tahoe on the border of California and Nevada. This is an older burn. This is the Calder fire burn from 2021. And then over to the west are irrigated areas. We're actually looking at a false color composite from 2 days into the fire on September the 8th. This particular image was generated mainly using OLI aboard Landsat 8 and 9. And you can see which source of data is providing the image by clicking these on and off. And if we zoom in a little bit, you can see this is the area that has already burned in brick red, and there are active fire fronts on multiple sides of the fire and lots of smoke emanating out. We can also make use of the active fire detections to look at the progression of the fire. So if we hop forward to September the 12th and look at a week's worth of active fire detections, and for this we'll use the active fire detections from Veers on NOAA 20, and we'll just give it a moment to load. Okay. Now we're looking at all the active fire detections over the first 7 days, so the 6th through the 12th. I have this the display set to time-based, and so we're actually looking at these based on when they were detected. So orange and red are the most recent, and again, this is days since detection. All right, so we have made use of the false color imagery as well as the active fire detections to look at the onset and progression of the fire over the first week. And to help users assess areas that have been burned, we've recently incorporated a number of vegetation indices from the HLS dataset that are available under the HLS imagery dropdown, which I'm showing over on the right. So let's fast forward to further into the fire. So on the 25th of September, we're now looking at a false color composite from the 25th of September. And if I change this to 1 day and give it a moment to load, let me zoom in to the area. And so this is the area that has burned, that appears in brick red in this false color composite. And now we're going to make use of the normalized burn ratio, or NBR. So let me pop that on. And the NBR from Landsat OLI is calculated using infrared and shortwave infrared bands. That's bands 5, and then bands 7 of the shortwave infrared. And the NBR can be useful, firstly, in mapping the extent of the burned area. In this palette, purple shows vegetated areas and shades of orange show burned areas. Secondly, the NBR can help in assessing burn severity. Darker orange areas generally indicate more severe burning, so more damage to vegetation, increased bare or exposed ground, presence of ash, etc. But it's important to note that the NBR can be impacted by terrain effects, so things such as steep terrain, shadow, etc., of which there was a lot in this area. And then, as I mentioned, increasing shades of purple generally indicate healthy vegetation or only lightly burned areas. The third way that the NBR can be helpful is in planning vegetation recovery and post-fire response activities. All right, so keeping this image in mind, let me now change the date to 3 years later on, so 3 years post-fire, and there was actually a good image available on the 24th of September. Okay, so now we can see more shades of purple, indicative of recovering vegetation and undamaged or healthy vegetation, and lessening shades of orange. Remember, there was a lot of orange in this area. And the orange is indicative of damage to vegetation, burn severity, etc. And if we pop on the false color composite, we see more shades of green, which is indicative of the vegetation recovery. And I have loaded up the image that was collected after the first several days of the fire, and all of this is burned area throughout here, and then this for comparison 3 years later on. So we can look at 2 snapshots now, the freshly burned and then 3 years after. And with this, we can start to assess the magnitude of change that has occurred in the recovery of vegetation over time. In addition to the normalized burn ratio, we also have available the normalized difference vegetation index, or NDVI, the normalized difference moisture index, and then the normalized burn ratio too. And each of these can be explored after the webinar using the information tool. At the bottom of the interface, I wanted to highlight that all of the bands for both Sentinel as well as Landsat, so the 10 Landsat bands and the 12 Sentinel bands, are available so that you can generate your own customized band combination using the bands that are available. You can also download the Modus and VIA's burned area products for using a GIS, for example. You can navigate to the page using the downloads option here, or you can access it over on the left via the download archived data from this dropdown. The files are available in HDF, GeoTIFF, or shapefile format, and download instructions are detailed in the user guide. So the Modus user guide is here and the VIA's user guide is listed here. There's also additional downloading guidance noted at the bottom of the page here.
Thank you so much, Jenny, for your demonstration on the burned area monitoring and post-fire dynamics. And now I'll send this off to Diane Davies, who will talk about the smoke and aerosols mode in firms. After a little bit of background information, Diane will demonstrate an overview of the smoke aerosols mode in firms, as well as tracking smoke and aerosols using the OMPS aerosol indices and corrected reflectance imagery. Thank you, Diane.
Great, well, welcome to this demonstration on using NASA firms to monitor smoke and aerosols. By the end of this session, you should know how to use firms to track smoke from routine fire events all the way up to extreme pyrocumulonimbus or fire-induced events that can inject smoke into the atmosphere. So let's get started. First, I wanted to just establish our foundation that when we talk about aerosols, we're referring to tiny particles suspended in the atmosphere, and these come in many forms. We have natural aerosols like sea salt from ocean spray, dust from deserts, pollen from plants, and volcanic ash. We have human-generated aerosols from vehicle emissions and industrial pollution, and then we have fire-generated aerosols, and this is where smoke fits in. So a key concept from this is that smoke is simply a type of aerosol. It's made up of tiny particles from burning vegetation, and because it's suspended in the atmosphere, we can track it using satellite instruments. And that's what makes firms so useful for smoke monitoring. And why does this matter? It matters because smoke doesn't just stay local. These particles can travel hundreds or even thousands of kilometers from their source, affecting air quality far from the original fires. So understanding smoke as an aerosol helps us use the right tools to track its movement. So what tools does firms give us for tracking aerosols? Well, we're going to be looking at the smoke and aerosols mode, and I think there are three main data sets that are extremely useful. First, we have visual detection through corrected reflectance imagery. So firms through NASA Gibbs provides true color imagery from multiple satellites. So we've got the MODIS instruments on board Terran Aqua and the VIIRS instruments on SUMI MPP, NOAA 20 and NOAA 21. And this imagery shows us what the Earth looks like from space, as our eyes would see it, making smoke plumes look clearly visible against the landscape. I should just note that in the advanced tab of firms, which I'll come to later, we also have the harmonized Landsat Sentinel imagery, which has a 30-meter resolution, but it's only available 2 to 4 days after satellite overpass. And I know that's been covered in some of the other training sessions. So in addition to the visual detection, we need quantitative measurements, and that's where the OMPS aerosol index products come in. OMPS, or the Ozone Mapping and Profiler Suite, was originally designed to measure ozone, but it excels in detecting aerosols. In firms, we have 2 OMPS aerosol index layers, and we'll discuss those in a moment. But I just want to mention active fires because, as I mentioned earlier, smoke is just one type of aerosol. And so adding in the active fires helps us distinguish what sort of aerosol we're looking at and make us more confident that we're looking at smoke as opposed to dust, for example. And in my example, we'll look at both smoke and dust. So I mentioned that firms actually provides 2 related OMPS aerosol index products. It's actually the same index, and the value is related to both the thickness and the height of the atmospheric aerosol layer, but they have different values. So understanding when to use each one is key to successful smoke monitoring. The standard OMPS aerosol index has a range from 0 to 5, and this works perfectly for most smoke and dust events. Values above 5 are actually filtered out of this product because they're considered too extreme for routine monitoring. But what happens when we have extreme fire events? Well, that's where the pyrocumulonimbus or pyro-CB layer comes in. And this has a range from 5 to 50 and removes all that high value screening and is useful for identifying fires with dense smoke plumes. And it has effectively been used to track these pyrocumulonimbus clouds or thunderstorms generated by wildfires. And so it's useful to know when to switch between these 2 layers. We generally start with the standard product for routine monitoring and switch to the pyro-CB layer when you're dealing with extreme fire events or when you see gaps in the standard product. So let's just spend a moment looking at what these numbers mean and the resolution of the data. Okay, so this is very approximate, but generally for the standard OMPS aerosol index, values from 0 to 1 indicate clear or minimal aerosol conditions. Values from 1 to 3 show light smoke or dust. 3 to 5 indicate moderate smoke levels, and here's an important threshold, that when you see aerosol index values of 5, that indicates heavy aerosol conditions that can reduce visibility and impact human health. For the pyro-CB layer, values above 5 indicate dense smoke that's probably reached higher in the troposphere. I should point out that there's a bit of variation between the OMPS aerosol index products between SUMI MPP and NOAA 20. This should be rectified in the future, but for now, values above 7 from SUMI MPP and values above 10 from NOAA 20 suggest a likely pyro-CB event. And values from 20 to 50 indicate extreme pyro-CB events where smoke has likely been injected into the stratosphere. So temporally, we get daily coverage with near real-time observation within about 3 hours of satellite overpass. This global daily coverage is what makes OMPS so valuable for tracking smoke transport over long distances. In terms of the resolution, the spatial resolution, OMPS aerosol index from SUMI MPP has a spatial resolution of 50 by 50 kilometers. The newer NOAA 20 and NOAA 21 satellites actually provide higher spatial resolution for the OMPS aerosol index, and ultimately this will give us more detail in smoke plumes. But currently, FIRMS displays both the aerosol indices from SUMI MPP and NOAA 20 at a resolution of 50 by 50 kilometers. In the near future, we plan to enhance the resolution of the NOAA 20 OMPS data to 12 by 17 kilometers and add in the OMPS aerosol index data from NOAA 21, which will have a 10 by 10 kilometer resolution. And this is what that will look like. So I'm just going to switch out here. So now let's see this in action with a real world example. I'm going to walk you through the Canadian wildfire events that occurred in May 2025. So when you first go into FIRMS, you'll be in the basic mode. You can click on these horizontal lines at the top to go into the smoke and aerosols mode. And here I'm going to put on the corrected reflectance imagery from NOAA 21. And I'm going to zoom into, I've already set the date here to May 24th, 2025. And now I'm going to put on the active fires. I'm going to put on the fires for VIIRS NOAA 21, so they're coincident with the imagery. And you can start to see here that we can see some smoke plumes. So these are milky white against the landscape. And that's exactly how it would look to your eyes if you were viewing it from space. And you can see some cloud cover here to the left. And if I zoom out a little bit, you can also see there's snow to the north and there's ice in the Hudson Bay. So sometimes it can be a bit challenging to distinguish between clouds and smoke. And so that's why the active fire detections are very useful to help us to be sure that it is smoke. And now we're going to add in the OMPS aerosol index layer. And here you can start to see that we've got values in probably in the 2 to 4 range. If you want to look at the actual values, you can click on this opacity button here and you can change the values. So if you just wanted to look at values from 2, you can change it here, almost there. And there you are. You can also, if you want to be able to see through the cloud as well, you can change the opacity. So, sorry, if you want to see through the aerosol index, you can change the opacity here. So that's quite a useful tip. So this shows us where the smoke is, and the aerosol index starts to give us an idea of how dense the smoke is. And in this case, it's not very dense. But as we progress through the dates, you can see that the aerosol index values are getting higher and the smoke plume is getting larger and denser. So I'm going to scroll through a little bit more. All right. Now, watch what happens if I put on the pyrocumulonimbus layer. You can see that we now have, so I changed this to blue to make it really stand out. But again, there's a functionality here. This is the default. You can switch it to whatever color you like for your preference. But you can start to see that the smoke is being lofted high into the troposphere, and it's starting to transport well beyond the boundaries of Canada. So what I want to do now is I just want to switch across and show you an animation of this smoke plume. You can see, I'm going to put it onto repeat actually, so that you can see it a couple of times. So here we are, we've got, if you can see my cursor, we've got the smoke plumes coming from Canada. They go right across the Atlantic to Europe and onto Asia. And at the same time as heading out into the Atlantic, there's also a plume that goes up to the Arctic. And you might also notice that there are some fires occurring in eastern Russia. And you can see again that the smoke plumes are quite large there. Now you might notice that there's quite a lot of activity going on the west coast of Africa, north and west coast of Africa here. And so we're just going to take a look at that because in this case, it's still aerosols, but it's not actually from fires. So we're going to follow the same procedure. We're going to have a look at the corrected reflectance imagery. And I'm just going to scroll through to the third, I think it is. Yeah. So what we saw here was that we were seeing fairly high aerosol indices in the Sahara, and we can tell whether or not it's smoke or fire by looking to see if there's any fires close by and if we can see any smoke plumes, and in this case there isn't. And also if you turn this off, you can see that we have a huge dust plume coming off the west coast of Mauritania. And again, if I just zoom out, you can start to see, oops, just let it catch up. There we are, you can see the smoke plume coming out into the ocean, and there you can see the OMPS aerosol index. And I probably should have put this back down to the original value before I started. So there we go, it's approximately right. Okay, so there's an example of dust rather than just smoke. Okay, so the other thing that I wanted to look at was an example from India. So in northern India, there tends to be recurring seasonal haze and pollution that becomes trapped near the ground by seasonal weather patterns. And this can create unhealthy air quality. So here we are, we've jumped to India for November the 1st. And you can see here that we have these seasonal agricultural fires. This is where they burn the remaining stubble from after the rice harvest. So this stubble burning often creates haze and smoke. And again, if you use the time slider, you can see how this progresses. And this has been a source of contention often in the news in Delhi and northern India due to the poor air quality. So I just wanted to show you what a pyrocumulonimbus event looks like in firms. So I've jumped over to the advanced mode here, and we are looking at the VIIRS NOAA 21 imagery, and you can see that we've got very thick smoke here. We've got the winds going from kind of west to east, and if we put on the aerosol index, you can see that we've got quite high values, and if we put on the pyrocumulonimbus event, you can see pyrocumulonimbus layer, you can see that where you've got these gaps in the standard layer, it's filled in with the OMPS Pyro CB layer. So I'm just going to turn those off for a moment and just zoom in. So what we're actually seeing, the pyrocumulonimbus events, you can actually see them pretty well here. But what's happening is the higher values in terms of the aerosol index only show when the smoke has been lofted into the air and is being transported. But yeah, just to show you quickly what it looks like, I'm going to just put on the VIIRS 21 active fires. And again, just to show you here, if you want to kind of just match the daytime fires with the imagery so it's coincident. You can even, again, change the size of the pixel so you can really get a good view of the smoke. And in this case, what I just wanted to also show you is that in the advanced mode, we have the HLS layers, and I think we've seen these in previous ARSET trainings. But here you can put on the, I think it's the Landsat data. Yeah. And if you zoom right in again, you can see that thick smoke that's funneling up into the troposphere, and then being lofted across. And I think it's so these pyrocumulonimbus events, we've seen quite a few of them this year, and in previous years, I think 2023 had a record number of pyro-CB events in Canada. And these are very much smoke, fire-induced thunderstorms that can impact the weather and loft these smoke aerosols transport it very many kilometers. I just wanted to recap on when to use each product. So the standard OMPS aerosol index should be used for most situations for routine monitoring for smoke and aerosols. And the Pyro-CB aerosol index layer should be used when there are extreme events, when you think there might be fire-created thunderstorms or gaps in the aerosol index product. And then just by way of recap, I think FIRMS is particularly useful for monitoring and tracking smoke by starting with the true color imagery to give you a visual overview of smoke, potential smoke and aerosols. And then you can add in the OMPS aerosol index. And then I recommend that you add in the active fires to better distinguish between smoke and other forms of aerosols, and then switch to the Pyro-CB aerosol index if values exceed 5, and then use the temporal progression to track the fires over a number of days. And you can also use the orbit tracks and subdaily timeline for adding additional time context.
Okay, thank you so much, Diane and Jenny, and thank you very much for demonstrating those for us today. So just as a summary, today we looked at an overview of the available burned area data sets and post-fire imagery and indices. We had a demonstration of FIRMS burned area mode, an overview of available aerosol indices, and then a demonstration of FIRMS smoke and aerosols mode. Looking ahead to part 2, we'll be visualizing active fire information on static graph and interactive maps, analyze active fire information using a fire count histogram, overview of static thermal anomaly data available in FIRMS, and how to use that static thermal anomaly data information to identify thermal anomalies that are likely not vegetation fires. And just as a reminder, after part 2, we'll have a homework available, and it'll be due on the 3rd of December. Anybody who attends both live webinars and complete the homework by the 3rd will receive a certificate via email approximately 2 months after the completion date of this training. Here's the contact information for Jenny Hewson, Diane Davies, and myself, Brock Blevins, as well as a link to the ARSET website and ARSET YouTube channel. Thank you very much, and now we'll start the question and answer session. Okay, great. Well, let's just jump right into it here. Your questions have been coming in throughout the presentation, and we've been diligently getting to these as well as we can before this session, so we can jump right into it. We have Jenny and Diane on here, so we'll start off with question 1. Most of the satellite analysis is mainly for focusing on examining the incident that happened already, and satellite update intervals extend the damage further. Is there any possibility to predict or foresee the incident beforehand?
I'll take that, shall I, Jenny? Okay, so no, there aren't any specific layers in FIRMS Global that enable users to predict fires, unfortunately. And we have struggled with the idea of putting in some kind of fire danger rating globally, so that's just not available. as local conditions vary. However, firms has recently added vegetation indices from HLS, which Jenny showed, and these can be found in the advanced mode and include the normalized difference vegetation index and normalized difference moisture index. And these could be used locally to help monitor fuel conditions. For firms US Canada, there are a couple of layers which may be of interest. There's a US flag warning and a US fire weather watch. So these are watches and warnings issued by the National Weather Service, and their criteria varies for each National Weather Service forecast area. A fire weather watch is issued when there's a combination of dry fuels and weather conditions that support extreme fire danger. And the red flag warnings are issued when these extreme conditions are anticipated in the next 24 hours. Thanks, Brock.
Great, thank you very much. Second question. The HLS product is only available over US and Canada, or with Firms Global, can we access the data set?
Well, thanks, Brock. So the data are actually available in Firms Global. One thing to note that there is a delay in the data set. There's a lag of anywhere between 2 to 4 days. So again, the imagery is available in Firms US, Canada, as well as Firms Global. Sometimes it can be helpful to zoom out and just be a little patient so you can see the imagery actually load on the screen. And just to know, this is different than the Landsat active fire data, and they are only available for the US and Canada. So again, the HLS imagery are available globally with this slight lag time.
Question 3. Given that the firm's platform will not be updated temporarily as indicated by the notification, what alternative solutions can you offer us?
Yeah, thanks for the question. So there are no enhancements or updates being made to the website currently due to the lapse in funding, but the active fire detections and image products continue to be ingested automatically into Firms. Additionally, any outages or data anomalies that occur have been addressed as they've occurred.
Great, thank you. We'll see what we can do to swing back around and address question number 4. In the meantime, we'll move on to number 5. I'm working with working on generating monthly time series data sets of burn severity metrics over large spatial scales using MODIS. My main challenge is identifying appropriate pre-fire and post-fire time windows for calculating the NBR for each month. Could you suggest this effective approach?
So I'm actually going to invite my colleagues to address this, but I actually think this question will take a little bit of time to just think about and develop the best answer for. Diane, I don't know if you have an idea off the top of your head.
It's such a great question. I think we would be better off getting a proper answer from some of our science team to help answer this question.
And we do, as you know, we do answer all of the questions as soon as the webinar finishes and we have additional information available.
Yeah, that's great. We figure we might as well give a little bit more of a thorough answer to this. So please give a little bit of time to make sure that we can answer this as accurately as we can. Question number 6. Does the aerosol index correlate with the concentration of smoke plumes?
That is my understanding, that it's to do with density and height of smoke plumes. But again, I feel like this is a very technical question, and I will confirm once we circle back with the final answers. unless anybody else on my team would like to chime in.
I am in agreement, Diane. I think addressing this when we have additional information, that will be ideal.
Great. Once again, in the sake of accuracy, please give us a moment on that one. Question number 7, is there some way to use ARMS in a geostationary satellite?
So ARMS is on board SMPP, NOAA 20, NOAA 21. These are all polar orbiting satellites versus the geostationary satellites, such as goes east and west.
Question 8, can we use this data to predict when First Nation communities should look at evacuation? So it just looks like emergency response and
Sure. We would caution against that. The data are provided as is, and we take no kind of responsibility for it being used in evacuation circumstances. We would rather advise that you use local knowledge on the ground. Obviously, sometimes people find the data is helpful, but please remember that the data is near real time, so approximately 3 hours after satellite overpass, and these are polar orbiting satellites, so they're not constantly updated throughout the day. We have the geostationary satellites, which do have, they are updated throughout the day and night. However, the spatial resolution of those pixels is not really good enough for that kind of decision making, I would say.
Great. So the geostationary data has a higher temporal, but maybe the trade-off being spatial.
Yes, thanks for that clarification. Yeah.
Question 9: are temperatures of the temperatures of the fires available?
I was trying to find the unmute button there. So the radiative power, or FRP, which is the energy of the fire, is available in the attribute information of the active fire detections, and this can be identified by actually clicking on the active fire detection, which will bring up the attribute information for each of the detections.
Question 10: based on the workflow provided, are there structured guidelines on how to properly reference the data acquired?
We do have that information. We have a something you can use when you're using our data, and we will pop that in the chat as soon as I can find it. It's under data use and data use guidance and disclaimer. So let me put that in the chat for you.
Great, thank you very much. And I'll also include that link in this document for future reference too. Okay, and then question 11. Are these layers only applicable in Google Earth Engine, or can they also be used in ArcGIS Pro, as that is the main software used at my institution?
Yeah, so I'm rapidly putting the answer in here. So the burned area products are available in HDF, GeoTIFF, and shapefile format, and certainly the GeoTIFF and shapefile can be used in ArcGIS Pro. And there is information on the FEMS website. If you look under download archived data, so those can be downloaded and used in ArcGIS Pro. Additionally, the active fire detections are available in multiple formats, including CSV and shapes, and so they can also be used in ArcGIS Pro.
Okay, so I don't see any other questions adding to the question and answer box. If you're not able to find that, please look for the 3 little dots on the left lower corner of either your application or your web browser, and you can see a Q&A section where you can answer your question or ask your questions, and we'll move those over to this document. What we'll end up doing is cleaning this up for accuracy, and then posting this ideally within a week. So hopefully before part 2 next week. We can have this available on the website for your reference. Which sensor characteristics are essential for accurate detection and retrieval of atmospheric aerosols from satellite observations? So I guess it's just a comment on some of the characteristics, yeah, of the sensor. Okay.
Oh, everybody's really challenging us today. I couldn't give you a good answer to that either. I'm really sorry. I think we'll have to circle back to you.
Okay, so we'll bring this question to the science team, and so look for this answer once we post to our training webpage.
Yeah, I should just say that, you know, we work very closely with our science teams, and they provide us with all the this type of information, and we aim to make it easily accessible through firms. So apologies for not being able to answer those questions.
Oh, we see a couple more pop in here. This one seems to be a little bit more of a use case or hypothetical, or maybe there's some case studies doing this, but how can satellite monitoring help in estate management? So I'm guessing this is mitigation or preparedness.
I can take a stab at that. I guess, you know, you can look at things like which areas have burnt over time. That might be useful for understanding fire regimes in your particular estate or area of interest. You can also look to see which areas have burnt, and so you might get a better understanding of which areas are more likely to burn in subsequent years or fire seasons. Again, you know, I mentioned earlier on that we have vegetation indices from the HLS data. Again, that might help you understand what your vegetation conditions are like and give you a sense of whether or not it's more likely to burn. And the same thing for the active fire data. You know, again, you can look at fire patterns over time. We also have an email alert service, which is freely available. So if you wanted to put your coordinates in, we could send you an alert when there's a fire in or close to your particular area of interest.
Question number 14, you mentioned a 2 to 6% difference in fire detection between MODIS and FEARS. One trend can bias higher than the other. And it looks like we have, yeah.
Thanks for that question. Sorry, Brock, to interrupt. In fact, all of the information on the intercomparison between the MODIS and FEARS burned area products is available in the Giglio et al. Paper, and I have pasted the link for that paper in the question.
We'll just tackle these last two here real quick. Confirms detect some greenhouse gases.
So the active fire detections and the burned area products, that they don't directly detect any greenhouse gases, but they can be used in the calculation of different greenhouse gases. And Diane, I don't know if you want to add any additional information to that.
Question 16, what are the strengths and limitations of OMS aerosol index products for detecting low altitude smoke versus stratospheric smoke for aerosols?
Yeah, another excellent question, and we can certainly consult the science team members to get some more information on this.
And I would just from having spoken to the science team recently in preparation for this, I can say that generally it would be, you know, you can use, so the lower aerosol index values indicate that you've got low altitude smoke, and you can look at the corrected reflectance imagery to try and verify this. And we will circle back on this answer to make sure we have it correct. And when you have much higher AI values, so you would be looking at the Pyro CB layer here, so values above 5, that's when you're more likely to have these dense smoke that's gone higher into the stratospheric into stratospheric layer. And I'd say that, you know, higher the value, the more likely the smoke has gone higher up.
We are at time here today. I want to respect everybody's day. Thank you very much for joining us for part 1 of this series. Hopefully you had a chance to take this training for the intro one back in April. If not, all the recordings, videos, homeworks are available so you can self-pace through it. But we wanted to offer this one to highlight some of the additional features that have been incorporated into firms. So thank you very much, Jenny and Diane, for showing us those. And please join us for part 2 next week. And thank you very much for joining us, and we'll see you next week.